Hi everyone, welcome back to Learning is Fun. This is the pre-algebra tutor of this set of lessons. So in the previous videos, we kind of did a new review of exponents, and I have it written off over here to the right hand side, just so that way if we're going through this video and you say, wait, hold on, stop. What the hell is an exponent? There you go, you have the definition. It's a base raised to a power. That whole thing is an exponent. Alright, capiche. So now in this video, as you see by the title, we're doing the rules of exponents. Alright, now I'm gonna give you the definition of these rules. We're gonna look at some examples. But I just wanna preface it by saying, so remember, the definition of an exponent is a base raised to the power. In every single one of these rules that I'm about to give you, you cannot do it. They just do not work out if the bases are not the same. So for example, our first rule, alright, and I'm going to write it out like you will see in a mathematical textbook, and then I will kind of tell you what each one means. Alright, so we're going to have a raised to the power of n, so a base raised to a power, multiplied times a raised to the power of n, alright? So again, the base can be anything and the power can be anything, it doesn't matter. The a, as you're going to see in a minute, the a might be 5, and the n and the m might be 8 and 25. It doesn't matter. So what we're going to do is 8 raised to the power n multiplied by a raised to the power m. Notice the bases are the same, or what we say in mathematics, they are equivalent. Alright, I will give you an example later on in the video where if these two were different, this rule, just forget about it, just toss it out of your brain. Alright, so a raised to the power n multiplied by a raised to the power m. We're going to get a, just one a, alright, because the bases are the same, a raised to the power n plus m, alright? So now we're going to go from having a product to having a sum, alright, or what we get when you do addition. Alright, so let's look at a couple of examples, and I'm going to go kind of quick on these. Alright, so let's say we have 2 squared times 2 cubed. Alright, notice I said I used a couple different terms. I didn't say 2 raised to the power of 2 times 2 raised to the power of 3. Alright, this means 2 squared. If you don't know why, go back and look at our basic math tutor videos. And again, this means 2 cubed. Same thing. Alright, so we have, normally this would be a product, but we can write it as 2, alright, the bases are the same, 2 raised to the power of 2 plus 3. And we're going to get a new exponent of 2 raised to the 5th power. So without doing everything I just did, alright, and it's, it might tell you, rewrite 2 cubed times 2 squared times 2 cubed, you can say, oh, well, that is the same thing as 2 raised to the power of 5. In fact, I want you to get to that point where you might see something like that and say, oh, well, that is going to be rule number 1 of exponents, which says that if the bases are the same, you add the powers. So another example, let's do 100 to the 5th power times 100 to the 200th power, alright? Now, you might see this and say, oh my god, 100 raised to the 200th power, that's gonna take me 2 years to write out. No, because, again, remembering rule number 1, so we can do that in a mental test at seconds in the head. Are the bases the same? Yeah, so we just put down one base, alright, and what does the rule say? I'm going to add the power, so at 200, so the power, we went from 100 raised to the power of 5, multiplied by 100 raised to the power of 200, or 100 to the 200th power, down to 100 to the power of 5 plus 200. We're going to be 100, sorry about that, 100 to the power of 205. And again, without doing all this fancy stuff we did, you can say this means the exact same thing. Alright, so let's apply it. Now we did some little definitions and some examples. Let's apply it now. So another example, and if you haven't gathered by now, EX9 means example in my world. Alright, so let's do let me come up with a quick one. Let's do 5 squared multiplied by 5 to the 5th power. Alright, so are the bases equivalent? Are they the same? Yes. So I'm going to have a new base of 5. The rule says to add the two powers together. So we're going to do 5 raised to the power of 2 plus 5. That's going to give me a new exponent of 5 to the 7th power, or raised to the power of 7. And not right now, but in later videos, we're actually going to solve 5 to the 7th power, which let me just let you know, it's going to be a really, really big number, and that's why you're going to need a calculator. And I'm sorry, I may be a very good math teacher, but even I need a calculator to do computations that big. Alright, so let's look at a couple more examples real quick. And that's why I like doing these videos on YouTube so well, and they're also going to be on the website. I will put the name of the website down in the box below this video. But you can go back, pause the video, and rewatch it a million times until you get the material down in your noggin. That's why I like doing YouTube so much. Anyway, alright, so let's look at a couple examples, alright? So we're going to do alright, so let's go kind of 9 by 9 here. So we have 2 squared, or 2 raised to the power of 2, times 2 to the 100th power, or 2 times 2 raised to the power of 100. So we're going to do 2 raised to the power of 2 plus 100, which is going to give us a new exponent of 2 raised to the 102nd power, or to the power of 102. 2 to the 4th times 2 to the 4th. Well, according to the rule, we just add the powers. So this is going to be 2 raised to the power of 8, or 2 to the 8th power. Keep going. So are the bases equivalent? Are they the same? Yes, we're going to write 105. Alright, so we're going to do 105 to the power of 2 plus 8, which is going to give us 105 to the 110th power, or to the power of 110. And again, don't be intimidated by such a big number. Yes, this says 1000 to the 8th power, 1000 to the 3rd power, or 1000 cubed. But are the bases the same? Yeah, they are. So we're not gonna get intimidated. We're just gonna write 1000, and then the rule says to add the powers. So we're gonna do 1000 to the power of 8 plus 3, which is going to give us 1000 to the 11th power, to the power of 11. So you kind of see all these are not intimidating. Why? Because the bases are equivalent, or they're the same. Now, let me show you an example real quick of this rule. Well, this rule does not work, alright? You do need to computate or calculate each exponent individually. And that's where the 1000 to whatever power comes to be pretty intimidating, and you need a calculator for that sort of math. Alright, so let's say I have an exponent of 2 squared, 2 raised to the power of 2, multiplied by 3 squared, 3 raised to the power of 2. Are the bases the same? No, they are non-equivalent. So therefore we're going to have to do 2 multiplied by itself 2 times, 3 multiplied by itself 2 times. So at first you can, I don't recommend this in later on videos, but you can do 2 times 2 times 3 times 3. Alright, so we're going to do 2 times 2 times 2, which is 4. Alright, 3 times 3, which is 9. 4 times 9, if you do not know your multiplication, tables, go back to the Basic Math Tutor. 4 times 9 is 36. So what is an easier way of writing? So you can say, again, with rule number 1, it should come naturally. 2 squared times 2 cubed is going to be 2 raised to the power of 5. That took me less than a second to do. The same thing here. You can say, well, what is going to be the end result? 2 squared times 3 squared. Well, we already know that's going to give us an answer of 36. Now, most of the time when you are in a math class and you do something like this, that's going to be okay. Only when the direction says to solve 2 squared times 3 squared, then you're going to have to write it out at 2 times 2, 3 times 3, 4 times 9, 36. But otherwise, like in a basic math video like this, just writing out the answer real quick and simple is going to be very helpful to you to keep moving quickly. And like I said, it helps to know your times table. I mean, if you have to, I have a friend, his name is Roman, and, he's 21, he graduated high school, he done a couple classes at CNM, UNM, but he's the type of person where if I write out 4 times 9, he has to do the finger counting, alright? Now, it's okay to do finger counting. I'm not getting mad at people for doing finger counting. But when you are in an algebra class, when you are doing a final examination that you only have a 20-25 minute time period to do it, you're not going to have time to finger count 4 times 9. That's why it's very helpful to know your multiplication tables. Alright, so rule number 1, a raised to the power n times a raised to the power m. You are just going to add the 2 powers together and to get the new exponent. Alright, when you see something like this, a raised to the power n divided by a raised to the power m, many people see this as division and they freak out. And it's okay. Division or fractions are the same thing. I don't know if you knew this, but fractions are just division. It's okay, division can be intimidating, especially when you do non-division. That takes like 10 minutes just for a simple problem to do. But this, an exponent, is so easy to do, people. It's just like rule number 1. So rule number 1, we are taking 2 exponents that we are supposed to be finding the product of, and we are adding the powers. With division, what we should be finding is the quotient of these 2 exponents. We are just going to do this. So are the bases the same? Yes. So we're going to do a raised to the power n minus m. So now we are finding the difference. Alright, and finding the difference of any math problem is so much easier than finding the quotient of a math problem. Finding the sum of a math problem is so much easier than finding the product of an exponent of a problem. Writing out 2 to the 500th power is better than writing 2 times 2 all the way to 500. Everyone thinks math is just kind of like this evil monster that makes our life so difficult. It's not. If you know how to do this kind of material, math is going to be your best friend. And how, you might say, oh, well, Dom, how can you be so sure about that? Because when many of you are probably high school age watching this video right now. When I was your age, I hated math. Math was my strong enemy. And I was horrible at math. I mean, talk about finger counting. I had to finger count literally everything in math. I was horrible at it. But as I learned kind of like the rules of mathematics, I got better at math. And the more I got better at math, the less I viewed it as my enemy and the more I viewed it as my friend. And I mean, look, I have several PhDs in mathematics, and you need to be pretty smart, and you also need to think of math as your friend if you're going to get a PhD in mathematics, let alone do it. Alright, so what are some examples real quick of this? Alright, so let's do 2 cubed over 2 to the 5th power. Alright, now I did this for a purpose, for a reason, because any of you, if you are able to do mental math, and you're going to say, okay, well, so let me just write it out, 2 raised to the power of 3 minus 5. Hopefully you should know this is going to give us a negative number, alright, and negative powers and exponents are in a special class of themselves. In fact, they're going to be a different video, and probably not until we get into the Algebra Tutor session. That's where we're going to deal with negative powers and powers of 0. Now, real quick, let me do it because I'm on the topic. Normally when you multiply anything to 0 is 0. It's almost the same thing in exponent. Anything raised to the power of 0 is going to be 1. So just real simple. Again, we're going to get into the more complicated material in the Algebra Tutor. But anything raised to the power of 0, you're going to get an answer of 1. It doesn't matter. It can be 5.800 million raised to the power of 0. You're going to get the answer 1. It can be 5.21589 thousand raised to the power of 0, you're going to get the answer 1. Anything raised to the power of 0 is going to be 1. Putting that out there right now. Alright, so we all know 2 raised to the power of 3 minus m. We are finding the difference. So 3 minus 5 is going to be minus 2. Alright, and how do I know that? In mathematics, it's all about checking your work. Alright, 3 plus what is going to be 5? 3 plus 2 is 5. So that's how I know. And since we're subtracting or we're finding the difference, it's going to be a negative, not a positive. Alright, let's do a better example that's not going to give us a nasty negative number. Alright, so let's say we have I'm going to kind of go with this pattern here, 2 to the power of 10, or 2 to the 10th power, over or divided by 2 raised to the 5th power. Alright, so 2, because the bases are the same, 10 minus 5 equals 2 to the 5th power. This is the same thing as this. This is the same thing as this. This is what I want you to get used to by saying, okay, oh my god, I have a scary exponent. Look at this. 2 raised to the power of 3 divided by 2 raised to the power of 5. Oh my god, gonna take me a whole year to do non-division and all this stuff. No, don't worry about that. Just remember, if you are multiplying two exponents, you are gonna add the powers. If you are dividing two exponents, you are gonna subtract the powers. We're gonna do one more example and then we're gonna end this video. Not one more example, one more rule, and we'll do another video soon with more rules, because in all actuality, there's probably about anywhere from 10 to 15 rules of exponents. Don't worry, we're not going to do all 15 to 20, alright? So let me write it over here real quick, just what we have. AN times AM is AN plus M. Alright, the second one is AN over AM is AN minus M. Alright, the third one. This is rule number 3. Alright, we have a set of parentheses. We're going to do A to the nth power, and we're going to take that whole thing and raise it to the power of n. Alright? So, again, that looks pretty intimidating, right? But let me put it in a real easy to solve example, and you will see it's not so intimidating here. Alright, example. 2 squared raised to the power of 3. Alright? So, if you remember from the order operations, or penders, of course where I'm from, where it's from Australia, we say benders, it's the same thing. So we know that we do what's in the parentheses first. So 2 squared, or 2 multiplied by 2, is going to give us a product of 4. 2 times 2 is 4. We're going to take that and we're going to multiply it against itself 3 times. 4 cubed, which is 4 times 4 times 4. If you don't know how I got 32, just do 4 times 4 is 16. 16 times 4 is 32. So what I want you to do in between now and whenever I put the next video up, so let me watch this here. AN is AN times N. So, do you see a pattern here real quick? If you are multiplying two exponents, you're gonna find this. You're gonna add a power. If you are dividing two exponents, you're gonna subtract the 2 powers. If you are multiplying one exponent times another power, not exponent, power, then you are gonna multiply the 2 powers together. Alright? So it's very simple. Again, we do have a website. It is learningisfun16.webnode.page. You can also email me at olsen.dominic45@gmail.com if you want, kind of a step-by-step process on how to do these rules and anything else we have learned in this video. Thank you. We love you. Have a great day. See you later.